Hello guys, welcome to Elif Math Studio. Today we'll be doing a secondary 3A math topic called logarithm. Okay, so let's start on this topic. Okay, the first one, logarithm. Every time you see LG in logarithm will actually represents log base 10. So LGA is actually equals to log base 10a. So for all logarithm, we will usually have a base and then followed by the number. Okay, so every time if you see LG, it represents log base 10. Next one, if you see Ln, is what we call as ln function, is as good as log base e. It's actually exponential. Okay. Next one, the next property, important, you have to know the properties. Sorry, you have to know the properties. Okay, next one, log base AA is actually equals to 1. It's actually equals to 1. Next one, log base A1 is actually equals to 0. And next one, log base AB equals to C. Let's say I want to make A the subject. Sorry, let's say I want to make B the subject. What must I do? On the left hand side, A is actually what we call as the base. If we bring it over, A will be the base as well. Then we ask me what happens to the C. C will just be the power like that. So it's B equals to A to the power of C. Okay? Next one, I'll do some examples for you. The question asks me to evaluate 3 log base 5 plus 6 log base 7 plus 8 LG10. So what you need to do? The answer equals to 3. What's log base 55? Log base 55 is actually as good as what? 1. So it's actually like that. Plus 6. What's LG? Log base 77 is also equals to 1. Plus 8. Because LG is actually log base 10. So what's log base 10? It's also 1 as well. The next step, we evaluate. 3 times 1 is 3. Plus 6 plus 8. So equals to 17. That's the answer for the first one. Okay, let's go on to the next one. The question asks me to evaluate 3 ln E minus 10 log base 9 minus 6 log base 55 plus 2 LG10. Okay, so this one is pretty straightforward. So it's actually equals to 3. Ln is actually log base E. So log base E is actually equals to 1 minus 10. Log base 99 is also equals to 1 minus 6. Log base 55 is also equals to 1 plus 2 and 1 as well. So just evaluate. So it'll be 3 minus 10 minus 6 plus 2. So what's 3 minus 10? Negative 7. Negative 7 minus 16 is negative 13. So answer is negative 11. Okay? Can? So actually I give you a few examples. Please go and try it yourself. Same thing. Go and pause the video. If you have any queries or any doubts on the formula, you can go back to the formula list right here. Okay? Okay, can? So please pause the video, go try all these questions yourself. Okay, the next concept we'll talk about, those are actually the basic rules of logarithm. Now we're going to do the laws of logarithm. Basically there are 4. Okay, the first one is this. Log base AX plus log base AY. So in this example, what you can see is actually the base are exactly the same. Okay, if the base are exactly the same and you decide to plus it up, the formula is actually just log base A x y. Okay, the next one, same base as well, both are base A, but now we are doing what? We're doing subtraction. So what does it become? It becomes log base A. If it's minus, then it will be x over y. X over y. Okay, the third rule, log base A x to the power of y. So for this example, what you can do with power y is that what you can do with power y is actually you can go and bring it all the way in front. You can bring the power all the way in front. So it becomes y times log base, y times log base ax. Okay, the last one, the fourth one, is actually what I call the change of base formula. So let's say I want to change this log base ax to say for example log base b. So it will be log base b. Pardon me. So it becomes log base b x over log, pardon me, LG is log base 10 now, so you can write that, is actually log base BA, like that. Okay, can? So these are 4 rules, laws of logarithm. We're going to try to use all these law of logarithm and with the basic concept we did just now to help us to solve this. So let's try first, the first one. Log base 8 2 plus log base 8 4. So in this example, what you can see is actually both base are the same. So what can you do? We can add up the power times the power. So it becomes log base 8 bracket 2 times 4. So it's actually equals to log base 8 bracket 8. What's log base 8? Basic concept is actually just equals to 1. That's the answer. Okay, next one, let's try. Log base 880 minus log base 810. So same base with minus, what do? We divide. So it becomes log base 8 bracket 80 over 10. So it's actually equals to log base 8 8. So answer is just 1 as well. Okay, we move on to the next one. Log base 2 8. So for this one, it's something like your indices. So the idea is actually to make the 8 into base 2 as well. So it becomes log base 2. 8 is actually 2 to the power of 3. Next one, what can you do with the 3 here? Well, based on the law, you can bring it all the way in front. So it becomes 3 times log base 2 2. So let me ask you, what's log base 2 2? Log base 2 2 is as good as what? 1 here. So what's the answer? The answer is just 3. Okay, the next one is this one. Log base 5 200 minus log base 5 8. So same thing, same base. We do a subtraction. So what we do 208, we're going to divide it. So it's log base 5 200 over 8. Okay, the next step, so it equals to log base 5. 800 over 8 is actually 25. So it becomes log base 5 5 square. So what can you do to 2? Bring it in front as well. So it becomes 2 times log base 5 5. So it's actually equals to 2. That's the answer. Okay, can? So I give you 4 examples. Please go and try it. You have to use the logarithm and the basic concept which we did in our section to help you solve for this question. Okay, next one. There are a few more examples from So the next one, let's try. 0.5 log base 7 9 minus log base 7 0.3. So the first step for this, although both are the same base, but you cannot straight away take 9 divided by 21 because we have a 0.5 here. So what must do? This one, you have to bring it up instead. So it becomes log base 7 9 to the power of 0.5 minus log base 7 21. What's the next step? So what's 9 to the power of 0.5 is as good as 9 square root 9. So it's equals to log base 7 3 minus log base 7 21. Same base, we minus. So what must we do? We divide. So it becomes equals to log base 7 3 over 21. So equals to log base 7 1 over 7, which is equals to log base 7 7 to the power of negative 1. So what can you do negative 1? We're going to bring 1, so just becomes negative 1 log base, pardon me, log base 7 7. Okay, so answer will just be negative 1. That's answer. Okay, can? The next one, log base 3 5 times this one. So same thing. For this one, you have to do what? A change of base. Change of base. So we actually you have to use the fourth one. The first one is actually base 3. The other one is actually base what? 25. So we have to adopt a change of base. You have to adopt the change of base. So for this one, if you I prefer to change to base 3. So for this one, you just write as log base 3 5 times this log base 3. So it becomes log base 3 3 over log base 3 25. What's log base 3 3? Log base 3 3 is as good as what? 1. Okay, so the next step equals to, so you can put as just log base 3 5 over log base 3. 25 is actually 5 what? Square. So you must ask me, what can I do to the 2? The 2 I bring all the way in front. So it becomes log base 3 5 over 2 times log base 3 5. So what can you do? We can cancel. So solution will just be equals to half. Okay, have to involve your change of base. The next one is this one. Log base 325 over log base 3, this one. So what you do is actually a lot of students go and did cancellation of like that 25 and this, which is wrong. You can't do that. Okay, how do you approach this question? Is actually you're gonna change 25. You're gonna change 25 and 125 into 5 to the power of something. So for this one will be just log base 3. Sorry. So it becomes log base 3 5 square over log base, sorry, log is not LG, please remember that. Log base 3 5 cube. So what's the next step? What can you do to the power 2 and power 3? You can bring all the way in front like that. So it comes 2 times log base 3 5 over 3 times log base 3 5. What's the next step? Cancel. So simply the answer is just tutor. That's the answer. Okay, so same thing. I've given you some examples. Please pause the video and go and try. Okay, can? The next one is actually, this next one is actually involve what I call as the reverse of law of logarithm. The reverse of law of logarithm. Okay, so what I need to do is actually we need to reverse the law of logarithm. Okay, let's try first. This one, x equals to log base 3 5 and y equals to log base 3 2. Express the following in terms of x and y. Okay, so the first one I write it out first is actually log base 3 10. Log base 3 10 to me is actually as good as log base 3 2 times 5. So what's the next step? We break it up. So it becomes log base 3 2 plus log base 3 5. Okay, so what's log base 3 2? Log base 3 2 we already know is actually what? The question is actually equals to y. So it will just be y. And then what's log base 3 5 is as good as x. So let's answer x plus y. Okay, the next one, log base 3 20. So equals to log base 3 20. So log base 3 20 is as good as log base 3 4 times 5, which equals to log base 3 bracket 2 square times 5. This one will be equals to log base 3 2 square plus log base 3 5. So what can I do the 2 here? I continue from here. The 2 here becomes 2 times log base 3 2 plus log base 3 5. So it's actually equals to what? Log base 3 is 2. It's actually just equals to 2y plus x. Okay, so whatever you do, you just have to use back this 2 will do. It won't go wrong. Okay. The next one, log base 3 0.8. So it's actually equals to log base 3 0.8. Okay, so for this one 0.8 you just have to put in terms of fraction to lowest term is as good as 4/5. The next step, if it's divide based on law of logarithm, if you reverse it, it should become minus. So it becomes log base 3 4 minus log base 3 5. So it's actually equals to log base 3 2 square minus log base, pardon me, log base 3 5. Okay, if we're going to continue, is as good as what? 2 times log base 3 2 minus log base 3 5. So we continue. What's log base 3 2 is actually what? So the answer is just 2y minus x. 2y minus x. Okay, can? Okay, so just simply just going to do the reverse of logarithm. The reverse of logarithm. Okay, let's try the next one. Let's do the next one. Log base 3 0.32. Okay, so I need to erase some of the working. Not enough space for it. Okay, give me a while. So first one, log base 3. So we log base 3 0.32. So this one equals to log base 3. 0.32 is as good as 32 over 100. So if you divide by 4 on both sides, so this one simplest term will be 8 over 25. Okay, so you can do as log base 3 8 minus log base 3 25. So it's actually equals to log base 3 2 cube minus log base 3 5 square. Okay, so what can you 3 and 2 bring in front? So it's just 2 times log base 3 2 minus log base 3 5. Sorry, it should be 2 times. Pardon me. Hold on. Minus 2 times this. So answer will be 3. Log base 3 2 will be y minus 2x. Okay? Can? If you do enough, you can actually see what's the idea behind that. So it's actually trying to make it into the reverse law of indices, then from there just try to work on it. Okay, next one. Log base 25 16. Because if you look at what's given to you, both the givens are actually log base 3. So for this one, you naturally change to log base 3. So it becomes sorry, log base 3 16 over log base 3 25. So same thing break down. So it becomes log base 3 2 to the power 4 over log base 3 5 square. So what's the next step? So it's actually equals to 4 times log base 3 2 over 2 times log base 3, pardon me, 5. Okay, sorry, this should be 5 square. Yeah, the handwriting is up. Sorry, pardon me about that. Okay, so becomes 4 and 2, you can actually go and cancel, so it becomes 2 and 1. So answer will just be log base 3 2 will be just becomes 2y over x. 2y over x. Okay, the next one. Log base 8 0.2. Okay, so same thing, change to log base 3. So it comes log base 3 0.2 over log base 3 8. Next step, 0.2 is as good as log base 3 5 to the power of -1, which is 1/5. Goes to log base 3 2 cube. So the answer will be negative log base 3 5 over 3 times log base 3 2. So log base 3 5 will be just negative x over 3y. Okay, so for this is actually a very good exercise. You actually reverse the law of a logarithm for you. Okay, so next example, next two examples is something similar. So please pause the video and go and try it yourself. Next section, we're gonna try to solve logarithm equations. So the first one, let's try this one. Log base 2x plus log base 2x equals to 5. So same thing, if you see both are the same base, and if it's plus, what you do? You multiply it up. So it becomes log base 2. X times 2x, it becomes 2x squared equals to 5. Okay, so the next step, you make 2x a subject. How do you make 2x a subject? This 2, we're going to push over. So it comes 2x squared equals to 2 to the power of 5. Okay, so it comes 2x squared. 2 to the power of 5 is actually equals to 32. Make x squared the subject. So equals to 32 over 2, which is 16. So to find x, we take square root of 16, which equals to plus minus 4. By logarithm, please remember that you can actually log base something in a number. This 2 cannot be negative. So the answer will just be positive 4. That's the answer. Okay, I try the next one for you. Same thing, same base. We do a subtraction. So what must we do? We divide. So it becomes log base 3. 2y over y minus 1 equals to 1. The next step, you make this a subject. Okay? Make this subject. Subject becomes 2y over y minus 1 equals to 3 to the power of 1. So after that, do cross multiplication. So it's 2y equals to 3y minus 3. Okay, next step, bring all the y's together. So it becomes negative y equals to negative 3 by bringing this one over. So y is actually equals to 3, just like that. Okay, same thing. Next example. Next for example is try it. Please go and do it yourself. Any problems, please refer back to our rules and then from there, try to work on it. Okay, next two examples is this one. Log base 2x minus log base x 4. So the idea is actually make them the same base. For this one, which one is actually lowest, 2 or x? I have no idea because I have no idea what x is. So for me, maybe a safer bet is actually trying to make to base 2. So it becomes log base 2, pardon me, log base 2 x minus log base 2 4 over log base 2x is actually equals to 1. Okay, so if you see something actually repeating itself, we go let it be another algebra. So write let y be log base 2x. So it becomes y minus log base 2 4 I can express as log base 2 square over y is actually equals to 1. Okay, sorry, my y is not very nice. So I will continue here. So it becomes y minus 2 over y is actually equals to 1. Next step, times everything by y. So it becomes y square minus 2 equals to y. So bring everything to one side because it's quadratic. So it becomes y square minus y minus 2 equals to 0. Factorize y minus 2, y plus 1 equals to 0. This means y minus 2 must be equals to 0 or y plus 1 equals to 0. What's the next step? It means that y must be equals to 2 or y is actually equals to negative 1. But the question doesn't start with y. We actually need to find x. So what you need to do now is actually replace back your this one by y. So it becomes log base 2x equals to 2 or log base 2x equals to negative 1. Make x a subject, equals to 2 square, x equals to 4. The other one, x equals to 2 to the power of negative 1, x equals to actually half. That's the answer. Okay, can? So what you do is actually change your base, and if you see something's actually repeating, what you need to do is actually replace it by an algebra and then solve it. Okay, the next one, okay, we erase all this first. If you need, please go and pause the video and then look through the working if you need to. Okay, so give me a while. Give me a while on this one. Okay, the next one is this one. Log base 3y square minus log base y 27. Okay, so the first step for me, maybe I change everything to log base 3. So first step, I do it here, ample space. So it becomes 2 times log base 3 y minus log base 3 27 over log base 3 y is actually equals to 5. Okay, the next step, since everything, so we let x be log base 3 so it becomes 2x equals to, not equals to, pardon me, it should be minus log base 3 cubed over x equals to 5. Okay, the next step, you do it here, so it becomes 2x minus 3 over x equals to 5. Pardon me. Next step, times everything by x, so it becomes 2x squared minus 3 equals to 5x. So it becomes 2x squared minus 5x minus 3 equals to 0. If we factorize, so it becomes 2x, x, it will be 3, 1, negative, plus equals to 0. So it means 2x plus 1 equals to 0, x equals to negative half, or x equals to 3. But same thing, we don't start with x, we must actually go and find the value of y. So replace it back into this. So write down as log base 3y, which actually equals to half, y equals to 3 to the power of negative half. Okay, y equals 3 to the power of negative half, calculator, 3SF value right here. The next one, log base 3 y is actually equals to 3, y equals to 3 to the power of 3, which is equals to 27. These are the two answers. Okay, can? So same thing, pause the video, and then now we have 4 more examples for you to do. Okay, the next one we have still a little bit more. Let's try first. The first one is actually something to do with indices. The idea is actually try to make them the same base. The idea is actually try to make them the same base. Okay, so the first one will be this. Change 9 to base 3 and change 27 to base 3. So becomes, this will becomes just 3 2 bracket 3c plus 1 equals to 3 to the power of 3 bracket 5 minus 2c. Okay, next step, power side by side, we times. So it becomes 3 to the power of 3 to the power of 6c plus 2. 6c plus 2, pardon me. It's actually equals to 6 to equals to 3 to the power of 15 minus 6c. So it becomes 6c plus 2 equals to 15 minus 6c. Okay, you bring all the 6c plus 2, so you bring all the c to one side, so it becomes 12c equals to 13. c equals to 13 over 12. That's the answer. Okay, for the next example, you can't actually make them the same base. So what you need to do now is actually what? You have to make in terms of logarithm, use logarithm or ln. So for this one, I can do LG on both sides. So it becomes LG 2 to the power of c minus 1 equals to LG6. Okay, what can you do with the power? We bring all the way in front. So it becomes c minus 1 LG2 equals to LG6. Multiply the LG2 in, so it becomes LG2 times c minus LG2 equals to LG6. Okay, so make c the subject, so LG2 times c equals to LG6 plus LG2. So c will be equals to just LG6 plus LG2 over LG2. Okay, just calculator, 3SF value. Okay, next one. For the next example, we can't actually choose ln. We can't choose between ln and logarithm, LG. For this question, you have to use in terms of ln. So, you just e to the power of 2x equals to 11. Pardon me. 11. So what I need to do, go and ln both sides. So it's ln e to the power of 2x equals to ln 11. What can you bring 2x? You can bring this 2x in front. So it becomes 2x. Ln e, what's ln e? Ln e is actually as good as 1. So just equals to ln 11. So x will becomes ln 11 over 2. 3SF value. Okay. Then for the next one. For the next one, because it's actually base 10, so for this you have to use LG. So it becomes LG, pardon me. So it becomes LG 10 to the power of 2c plus 3 equals to LG7. So bring the power in front. So it becomes 2c plus 3. Ln 10, what's ln 10? Ln 10 is as square as 1. So it's equals to, pardon me, LG7. So it's 2c equals to LG7 minus 3. C will be just equals to LG7 minus 3 over 2. 3SF value. Okay? Can? So the idea is actually, if you can make both of them to the same base, then after that, please go ahead and just compare the powers. Else, in the other 3 examples, you have to apply your logarithm, LG or Ln. Okay? So all these examples, please go and try it. Just please go and try it. Okay. Let me see. Okay, maybe I'll do one more here. A very common question in your examination as well. This one, you have to do substitution method. Okay. So the idea is actually try to make them to the what? Same base. Same base. So it becomes 2 bracket 5 to the power of x, the whole thing square, minus 3 bracket 5 to the power of x equals to 9. The next step, if you can see, is actually you can see every 5 to the power of x repeating. So same thing, you're going to replace it by algebra. So right here, y be 5 to the power of x. Let y be 5 to the power of x. So it becomes 2y squared minus 3y equals to 9. Quadratic, bring everything to one side, such that one side equals 0. Next step, we use cross factorization. We're going to use cross factorization. So it becomes, pardon me. So it's come bracket equals to 0. 2y, 3y, 3 negative and positive. So it becomes 2y plus 3 equals to 0, or y minus 3 equals to 0. So y equals to negative 3 over 2, or y is actually equals to 3. Same thing, the question doesn't start with y. What you need to do is actually replace your y back to 5 to the power of x. So it becomes 5 to the power of x equals to negative 3 over 2, or 5 to the power of x is actually equals to 3. 5 to the power of x cannot be negative. So for this one, we have to do for this one, that cannot be negative, so it becomes reject. Okay, 5 to the power of x equals to 3. So what you do, go and ln both sides or LG both sides. It doesn't matter, the answer will be the same. What can you do to the x? We can bring the x in front. So x times LG5 equals to LG3. X equals to LG3 over LG5. That's the answer. Okay, then put the 3SF. Okay, the rest, please try yourself. The last type of question you'll see examination is this one, what I call as logarithm exponential function. Okay, so let's try this one. Let's read first. The population P in town T years after this is given by this equation. P equals to P naught e to the power of KT, and P naught and K are actually constants. So population P after T years, that's what you do. At the end of 1980, after the population is actually 20,000. Find the value of P naught. So let me copy the equation found first. P equals to P naught e to the power of KT. The question say at the end of 1980. Okay, so it actually means what? Means what? The first clue is actually when T equals to 0. Your P is actually equals to 20,000. Sub these two values in. So it becomes 20,000 equals to P naught e to the power of 0k. Pardon me. E to the power of k bracket 0. What's k times 0? It's actually 0. E to the power of 0, this whole thing becomes what? 1. So it means P naught is actually equals to 20,000. So submit back the equation. So it becomes P equals to 20,000 e to the power of KT. Okay, next one. At the end of 1985, the population has grown to 2,201. Find the value of K. So same thing. At the end of 1985, your T value is actually equals to 5. Because it's 5 years later than 1980. Your P is actually equals to 20,201. 20,201. So sub it in. So it becomes 20,201 equals to 20,000 e to the power of what? 5k. Next step, throw the 20k over, so it becomes e to the power of 5k is actually equals to 2021 over 20,000. So what's next step? You go and ln both sides. Ln both sides, you see that is actually ln e to the power of 5k is actually equals to ln 2021 over 20,000. So it becomes 5k equals to ln 2021 over 20,000. K equals to ln 20,201 over 20,000 divide by 5. Divide by 5. Okay? I go and calculate this. Okay, so if you go and calculate this value here, let's try to use the calculator. Let's impute in ln 20,201 divided by 20k and divide by 5. So it's actually 2 to the power of negative 3. 2 to the power of negative 3, which is equals to just 1 over 8. Okay, can. So we sub k equals 1 over 8 back into the equation. So the equation should read as p equals to 20k e to the power of 1 over 8 t. That should be the equation. This will help you to solve for the next one. Okay, let me erase some of the portion because we don't have no much space here. The last part, find the population of Hwa X in 1998. So 1998 is that our t value is actually what, 18 years after 1980. So t equals to your 18. So just sub it in. So it becomes p equals to 20k e to the power of 1 over 8 times 18. Okay, just key in the calculator through SF. The last one. In 1998, in which year will population X exceed this one? Okay, so maybe I just erase this portion. In which year will the population exceed 21,067? 21,067. So same thing, you sub p equals to 21,067 equals to 20,000 e to the power of 1 over 8 t. Okay, so make e the subject, so it's actually e to the power of 1 over 8 t is actually equals to 21067 over 20,000. Ln both sides, so it becomes ln e to the power of 1 over 8 t is actually equals to ln 21,067 over 20,000. So it becomes 1 over 8t equals to ln 21067 over 20,000. Okay, so to find t, we take ln 21,067 over 20k times 8. So t, you give you a value. Okay, so let's try a key calculator. Ln 21,067 divided by 20k times 8. 2167 not 21, oh, 21,600. Okay, and then times 8. Okay, then after that, once you get the t value, what you do here is actually round up. Once you get this t value, you round up, then you take 1980 plus back the t value. That's actually the answer. Okay, can? So that's it for logarithm. Okay, so next question is something similar. Please pause the video and try it. So once you're done with all this, please head over to the assignments. Just try to head over the assignments and try to redo. If you can actually go and do all the question assignments, I think you're very good for logarithm. Okay, can? Thank you for your attention. That's it for logarithm.